All right.
I kind of like the trial by fire kind of stuff. It's a lot more interesting.
Well, I really wanted to show. It'll make more sense in a second. Make sure I've got the right screen here. Let's not do the tunnel of death.
I spray painted the poodle. I wanted to show it to you. Come on.
Yeah, okay, let's not share my screen. I painted the poodle.
There you go. That's a soundbite for
All
you.
right, so yay. Where are we? Where am I? I don't know. You tell me. Let's go ahead and look at the AI first, and I will stop doing this. And we will turn off the debugger. Sorry. I will run it. Now we get to see the game on the screen. Oh yeah. All right. So last week we talked about a couple of interesting things. First of all, you can see that I've got one enemy on the screen and he's moving super slow. The reason he's moving so slowly is because I have set. Come on now, come across. I've set some new variables in common, and one of them is called enemy min speed, and the other one is called enemy max speed. Now, normally that's going to be a range between 75 and 150. In other words, the enemy will move towards us at a speed of either 75 pixels up to 150 pixels per second. Now, for my testing, I made it really slow because I wanted to play around with shooting at the enemy and not have to worry about it killing me because I'm distracted as I talk. But last week, you asked me, Charles, about animations and scaling and stuff like that, and I talked about the timescale attribute.
Mm-hmm.
So the cool thing here is let me find the code and I'll demo it for you. So last week I showed you guys that sprites have this variable called, let me zoom in a little bit, called timescale. And what you can do is you can create a base animation that runs, let's say it's got 10 frames and it takes 1 second to iterate, so each frame takes 100 milliseconds. But then you've got a situation where you need to make that faster for one sprite instance and slower for another sprite instance. So what do? You've got two options. Your option one is to create more named animation sequences and use different sequences for different animations. So it's going to be the same frames, but then you could change the time to 2,000 or 500 milliseconds or something like that. But that's not very efficient. I mean, that's good if you know those are the only three you're ever going to need, like slow, regular, and fast. Good, you're set. But if you need to be extremely dynamic, what you can do is you can find a base speed that works for you, and then you can adjust it. And so what I've done here is, let's go ahead and put this back up to 75-100. What I've done here is I've created a variable called base speed. So my assumption is that the animation when it plays at normal rate should be considered normal for moving at 60 pixels per second, which is what I've set here. And then my actual movement speeds are going to be between 75 pixels per second and 150. So what I do is I say, let's go ahead and get the enemy speed. Let's find the code here. So we randomly select a value between the minimum speed and the maximum speed. And let's just assume that that's 75. In fact, I'll force it to be 75, just for this demonstration. And further on in the code, well, not very much further, I look at that speed, and then I divide it by the base speed, and that gives me the time scale. So, for example, if my speed were 120, and my base speed is 60, then my time scale multiplier is going to be 2. So in other words, play the animation at twice the normal rate, whatever it was set to in the animation sequence. So now I'm choosing 75, so let me go ahead and just run one of these for you. And stop it, and reload it. Reload it. And here's our guy walking, and he's chasing me around. And that looks, pretty good. Let's shoot him and get another guy. Oh, nuggets. I introduced a bug. Yay. Okay, well that's cool too. I love it. Okay, so as you can see, it looks good. The enemy is doing his thing, and it's all good. All right. Oh, there. Looks like I finally killed him. Oh, you know what I think's going on here? I've also added a feature for this show where I can cause these guys to when they generate on screen so you can see them. So anyways, let's go ahead and ramp up the velocity. Let's just stop this for a second. Let's ramp up the guy's movement speed to the maximum. Let's force it to always be the max. So to do that, I just simply set the min and the max to the same value. So when that random statement executes, which is right here, it's basically saying a random value between 150 and 150. So I'm not giving it any real choices. So now it's going to be 60 over 150 is my time scale, which is like, I don't know, what is that? Almost 3. So let's go ahead and see it. And this back and forth screen thing is kind of weird. Woo. Okay, now he looks like a freak. Freak, get away from me.
So now he's really chasing you.
Yeah, he's really chasing me. But you can see, woo, you can see his movement rate has sped up significantly. And I don't know why he's spawning or dying. So I've obviously introduced an error with this bug, or with this code, that I will have to fix. Oh, I think I know what it is. It's the timer. Okay, so what's going on here for people who are wondering why he keeps respawning when I shoot him is I'll show you the code that does this in a minute. It does his movement. But what it is basically is there's a timer. And, oh, that's nice. Now he's moonwalking. It's the moonwalking bug. Excellent. So let me get this back over here, and I'll show you the code.
Nice.
It's too funny. Let me make this a little bigger so everybody can see. So what's going on there is, let's just see. Let's see the. Oh, come now. So as you can see, this guy is constantly following me now. Like last week, our AI would walk to a point and then go, oh, he's not there anymore. And then it would turn and chase me again. Now what you see is basically every 1/10 of a second, it checks and sees, has the player moved? Has the player moved? Oh, he's moved. I need to go and aim at the new place where the player is. So over time, it's constantly updating the animation that it's playing and the direction that it's walking in to try to catch me. So as you can see, with just one player, I'm having, well, it's moving at 150 pixels a second. Let's slow this guy down a little bit.
So is that a combo of what we did last week, where you said?
Yeah,
hey,
yeah, it is, and I'll show you the code. And I just wanted to show you what it was doing first.
Okay.
This is probably too big now. So last week's code is right here. And just to reiterate what we did last week, basically what we do is we have this function called move to player, and I set it up one time, and then I call it below. Now I'm calling move to player 2, but just pretend that this still says move to player. So it calls it, and what that does is first it checks, is the game running? Okay, yes, it's still running. I can go on to the next line. Is this object still valid? Which is a function in the common code. And let's find it. It runs this little bit of code, and my valid check is basically, does it have a function called remove self? What happens is, on a side note, when you remove an object, the very next frame after it has been removed from Corona, there will probably still be a little Lua object left over, but the Corona stuff has been stripped off. And one of the things that's been stripped off is the remove self function. So if you've got a reference to an object and it doesn't have a remove self function, you know that it's been removed, it's been deleted, and it's on its way out, probably going to get garbage collected soon. So so I check to see if it's valid, and the reason I do that is because I'm going to do some things here where I'm going to call some methods on. I'm going to set a transition or try to modify it in some way, and if it's not a valid object, I could crash my game at this point, or at least cause a bug, or do something bad, and so I want to avoid that. And so I just check to see if the game is running, and I check to see if the enemy is a valid object, and then I start to do my work. And the work from last week, I'll run it again so you can see the difference, is we calculated a vector between the enemy and the player, so basically arrow, if you want to think of it that way, pointing from the enemy to the player. And then I got the angle out of that. I stored that aside so that I could use it to select the proper animation, because as you'll recall from last week, we don't actually rotate the enemy. We choose a new animation based on the rotation that it's supposed to be facing in, or the direction it's supposed to be facing. Then we get the length of that vector. So how far away is the enemy from the player in pixels or in design space? And then we simply grab our speed variable, and then we divide the length by the speed, multiply it by 1,000 to get it into milliseconds, and we use that for our transition time, which is right here. And then the only thing we do before we start to move the enemy is we set the appropriate walking animation with the angle that we are currently facing at. So, let's see. So this is last week, and basically what it did was it would walk to where the player was at the time that it started, and if the player wasn't there anymore, onComplete would fire, and using the trick that I gave you last week, you just pass in self, and down here I set onComplete to the function that I wanted to call, and it would just simply call the move to player function every time the transition got done. So it moves, gets to the end, calls this function again, does all these calculations, moves again. And so it's a big zigzag pattern that it just keeps trying to track down the player. So let's go ahead and see that one, and then we'll go back to this code in a second.